I discussed in the last lecture the limbic information. The second one is sensory information going into the thalamus. If you can remember, I said that all the informations, all sensory informations that we sense in our own environment, whether from external environment or from internal environment, they must pass through the thalamus with the exception of olfaction, that is sense of smell. But as I told you before, memory, emotional memory to do with the smell, that one passes into the thalamus. So now let us discuss about these sensory informations. We have different categories of sensory information. If, for example, we start with the sense of vision, like now you are all looking at me, you are seeing me, you know who am I, now you've seen what I'm wearing, and so on and so forth. So this information is being taken into your eyes. So as soon as this information, visual information, stimulus, reaches your eye, the information reaches the retina. We have the retina at the back of the eye, and that retina is a conglomeration of the cell bodies, that this information now, is taken to that area, the retina. And so the axons of these cell bodies in the retina, they now form what we call optic nerve. So this optic nerve, the fibers from one half of the eye and the other half of the eye, the one on the inner side of the two eyes, of both eyes, they crisscross, they form what we call, optic chiasma here. While on the lateral side they don't, they now go undeposited, So, but at the end of the day, this visual information, as it passes into the retina, it passes into the optic nerve. From the optic nerve, it goes into the optic tract. From the optic tract, information is being taken into the lateral geniculate body. From the lateral geniculate body, which is a group of nuclei or nucleus that is lying by the lateral side of the pulmina of the thalamus. So this information, as it reaches the lateral geniculate body, so some of the information is now being taken out of the lateral geniculate body into the visual cortex, that is the occipital lobe, at the posterior part of the cerebral hemisphere. So if you can remember, in the posterior lobe of the cerebral hemisphere, I discussed about three major areas with you. Area 17, Area 18, and Area 19. Are you clear? So after the information reaches the lateral geniculate body, information now gets out of the lateral geniculate body and be taken into the area 17. That is the primary visual area. And so the function of this primary visual area is to receive the information. That is, receive the visual information. Are you clear? So after the reception of this visual information, the information is now being taken to the area 18 and 19, which I will discuss with you later on. And so these areas of 18 and 19 are areas responsible for processing and analysis of the visual sensation, which we will get to know later on. Are you clear? So, but we now know that finally from the lateral geniculate body, information now is taken into the area 17. That is the primary visual area, and this radiation is what we call optic radiation from the lateral geniculate body. And this is virtually, in a nutshell, the visual pathway. Are you clear? Though it's not complete yet, but when we come to the actual visual pathway, we'll still, explain further about, the connections, with regard to the visual pathway. So we have now seen that lateral geniculate body is responsible for the reception of visual information from the light, lateral geniculate body, L for light. So we can remember that when you see light, now that light is taken into the lateral geniculate body. Are you clear? So the medial geniculate body, which is this one, is responsible for auditory function. So whatever I discuss with you now, you are hearing me. Are you clear? So this auditory information or stimulus is taken through our own ears. And in the ear, in the inner ear, ear is divided into three parts. We have what we call external ear, middle ear, and internal ear. So in the internal ear, there's what we call vestibulocochlear nerve. Vestibulocochlear nerve. This vestibulocochlear nerve is a combination of two nerves. One vestibular part, the other one is cochlear part. The vestibular part is responsible for, balancing. If you see me standing now, and I'm balanced, I'm not shaking or, trying to fall down. So I'm balanced as a result of this, intact vestibular component of the vestibulocochlear nerve. Similarly, the cochlear component of this nerve, which is the 8th cranial nerve, this vestibular, we have about a dozen of cranial nerve. So the 8th cranial nerve is what we call vestibulocochlear nerve. So the cochlear component of it is responsible for hearing whatever is around you. So you are able to hear me now as a result of this intact cochlear component of your vestibulocochlear nerve. So now from the internal ear, fibers will now pass out of the internal ear until they reach what we call pontomedullary junction. So that's what we call pontomedullary junction. This pontomedullary junction is the junction between the pons and the medulla oblongata in the brainstem. At that junction now, there are two groups of nuclei, what we call cochlear nuclei. There is one that is lying on the ventral side, there is one that is lying at the dorsal side. These are all what we call cochlear nuclei. One on the ventral side, one on the dorsal side of the pontomedullary junction. So as soon as this cochlear component now reach these two nuclei at that junction, so it synapse, the cochlear component synapse with these two nuclei. From the two nuclei on either side, they unite. Both the dorsal and the ventral, they unite. That of the right side, this is the right side, this is the left side. After fibers from the dorsal and the ventral, they unite, it passes toward the opposite side. So the one on the left side, as that happens, it crosses to the opposite side so that they crisscross at the level of the pons. You get my point? So this crisscrossing, or the crossation of these fibers, is what we call trapezoid body. You get it? So this trapezoid body is a union of, or the crossation of the fibers coming from both the dorsal and the ventral, cochlear nuclei that are located at the pontomedullary junction before they finally, pass upward to the opposite side. So now the one on the left-hand side, as it crosses toward the right side, it reaches the right inferior colliculus. In the back of the brainstem, especially the midbrain. If I now write, this is the midbrain here, this is the pons, this is the medulla oblongata here. So this is my midbrain. This is medulla oblongata. And this is, pons. This is pons. This is pons. And this is medulla oblongata. So at the back of the midbrain, there are two pairs of swellings. So there are two above and two below. These two swellings are just like balls, And so these ones that are above, they are called superior colliculi. Superior what? Colliculi. Singular is colliculus. So we have right and left superior colliculi. We have another pair below it, what we call inferior colliculi. Are you clear? So if I assume that this is at the level of our midbrain, you have superior colliculi here, you have inferior colliculi here. So these fibers, as they form this trapezoid body, these fibers from the left-hand side, as they pass upward, they bundle together, they go up as what we call, lateral lemniscus. Are you clear? So it forms what we call lateral lemniscus. So this lateral lemniscus passes upward to reach the inferior colliculus of that side. From the left side, crosses form trapezoid body, pass upward before it finally reaches the inferior colloculus. And so from the inferior colloculus now, fibers from the inferior colloculus, they pass upward until they reach the medial geniculate body. Are you clear? So now these fibers, as they pass from the inferior colloculus to the medial geniculate body, they form what we call inferior brachium. Are you clear? So that means we will also have superior brachium. When we discuss brainstem, people will get to know that. So now we have seen these fibers. So now from the medial geniculate body, where do you think the fibers will go? Temporal lobe. Temporal lobe. So they will now pass to the cerebral cortex at the level of the temporal lobe. Because if you can remember when we were discussing the temporal lobe, we said that its major function is audition. We have our auditory center located there, area 41 and 42. So from the medial geniculate body, they will go there. Are you clear? So we have now seen this auditory passage. So we have now seen the functions of the lateral geniculate body, the function of the medial geniculate body.